Hey everyone. So I didn't think I'll be like having an occasion to actually do a stream so soon after such a long break, but I think some pretty good occasion popped up. And I'm gonna use this as some sort of a excuse to actually watch some other tech YouTube videos. I think I've prepared like 3 for now, but maybe if anybody wants to suggest anything, then sure. That will be very welcome. Mm, okay, I kind of forgot, but I need to fix this up a little bit. Oh yeah, just like this. Okay. And I hope everything will be ready. So yeah, okay, so actually my main reason for doing this is that I actually uh, don't want to say starred, but I appeared in level 1 text videos about SC25, where I talked with Wendell about different stuff, various stuff. But I think it's nice to actually be able to watch this and react to this on a stream. But before we do that, there are some videos at least very recently, there is one video with kind of a very clickbaity title that I wanted to check out. So maybe without any further ado, let's go and watch I'm Uninstalling Windows by Jake. Oh.
I'm having a great time right now. It's been 30 minutes of trying to install one program. Holy. Do you ever feel like Windows just keeps getting worse?
By the way, do tell me if the audio levels, if you want something louder or quieter. By the way, this is a very clickbaity title, at least for me. Like, I know, like, hating on Windows is popular, but for me it's kind of cringe. Because if you worked in the field for some time, you do realize that every system has its use cases. And Linux desktop is, well, the topic for a whole another time.
It's almost like every week they add more bloat, ads, half-baked updates on features that
Okay. Let's slow down and let's see.
getting worse. It's almost like every week they add more bloat, ads.
Okay, do more with a new Windows 11 PC with new support. Makes it easy to move. Okay, so this is basically an upgrade from 10 to 11. Level up Okay, so basically, yeah, sure. Copilot is bullshit. I don't remember if Windows 11 is basically offered as a free upgrade from Windows 10, because upgrading from Windows 7 to Windows 10 for free was amazing, to be honest.
It's half-baked.
Microsoft finally fixes the infamous update and shutdown bug. Okay, so supposedly they didn't shut down, they rebooted back then. Okay.
Updates on features.
And Microsoft Store change removes the ability to stop app updates. Pausing automatic updates now limited to 5-week duration. I mean, hating on automatic updates in Windows is kind of weird. Like, I get why Windows is doing that. Because and even though, Windows forces those updates onto you, I think they are more likely following the FreeBSD model of updating the system. It's not necessarily like Linux. Like, I want to say not Linux, but like typical distro. But I kind of get why they are doing this. And to be honest, sure.
Features that already.
Microsoft explains why you can't move Windows 11 taskbar. You can't? I mean, last time I moved taskbar was when I was, I don't know, in high school. Yeah, to be honest, I don't see this option out in the open. Okay, it's still
work just fine and slide in AI crap.
almost 3 years later. It's time to admit that Microsoft Copilot was a mistake. I would say almost every AI early adopter product was a mistake.
Where it shouldn't be. Not to mention making it harder and harder to have any semblance of privacy.
Oh yeah, Microsoft recall, yeah. That sucks. But like I said, I guess I get why they're doing things this way. I come across this very often at work. So unless you come to the team, for example at work, with a ready-to-go feature or product for the team to use, and you'll tell them, start using, like you'll tell them authoritatively, start using this right now. Either nobody will ever use it, or some people will switch, some people will not, and then you will have split. I want to split team when it comes to tools they're using. So I kind of get this approach of forcing the feature for everyone, and then later on only maybe allowing people to disable it.
While you use the damn thing. I could go on, but I'm sick of it. I just wish there was something other than Windows that you could run on your PC, whether it's for business or for pleasure. Whoa, what's that? Oh, God?
Oh, Wendell. Nice.
Is that you?
If you shall have a task to make you an example in these dark times, to use Linux, because, well, I think you'll like it. It's probably fun.
Good idea, oh Lord.
Of course it's a good idea. Behold, look well upon this, Jake. This is us. This is your task. This is your mission. This is what you must embrace and construct and experience. Linux.
A blessing from the Lord.
God be praised!
Look well upon it. This is your quest.
But Linux is open source and I thought it sucks for gaming and is
Okay, I really like how Wendell is kind of becoming the go-to guy when you want to basically do some professional stuff with your hardware or with your Linux or with your whatever.
and hard to use. Sure, that's what we've been told, but thanks to Valve's massive economic dong, brute forcing Linux adoption with the Steam Deck and soon to be Steam Machine, and the huge buff that's had to the Linux user base, it begs the question, is it possible, hell, maybe even better to run Linux on your computer for gaming or productivity than Windows or macOS? And to find out, I'm going to spend the next month of my life locked away from both, daily driving Linux on every computer I own so that you don't have to. And who knows, maybe it's gonna be great.
Okay. So I wouldn't say that Steam basically with its products like made more people switch to Linux is basically like saying that like you know, if you say that people using Steam OS or Steam Deck are Linux users, it's almost the same as saying that Android users are Linux users. So I don't know about that. I do have some of my own thoughts about gaming on Linux, but let's see where this video goes.
Now, to be clear, I already use Linux in my home lab and on servers all the time. So the fact that I've never daily driven it is frankly kind of embarrassing. So delay no longer. Where do we start? Where do you download a Linux? This is where things already start to get complicated. You see, the Linux project at its core is just a kernel, which is kind of like the engine of your operating system. Naturally, it's a very important piece. It basically acts as the glue between your hardware and the software, but you also need a couple other pieces like, you know, tires and suspension and whatnot before we can take this proverbial high road to enlightenment. Now,
I wish they like collectively would stop making those weird analogies. Like, if Linux is only a kernel, just say what the kernel does and what it does not. I would say that would be much better than saying that it's an engine and you still need wheels and stuff like that. I mean, don't get me wrong, I like this guy. It's just some of my thoughts in general.
we actually want to download is a Linux distro or distribution, and those come with all those other pieces already included. You
What you're actually referring to is GNU Linux.
probably heard of distros like Ubuntu or Mint, except there's actually thousands of flavors, all the way from Hannah Montana Linux to whatever the this is. It's honestly a bit overwhelming, so I did what any sane person should, and I asked Twitter which distro I should use. Lesbian. What the There were hundreds of suggestions. I downloaded a sketchy Chrome extension that let me scrape all the replies, put them into a big list, and we were left with the Twitter Linux leaderboard, upon which 4 distros shone above the rest. We were left with the Twitter Linux leaderboard.
So Fedora, CatchyOS, Arch Linux, Bazzite. In my opinion, weird. It's weird to see that Fedora was first. To be honest, I've never daily driven Fedora or Red Hat based desktop distribution. I've heard they are supposedly quite okay, especially recently, and I would say this kind of reflects that. But basically what I did not expect was for, I want to say, some vanilla distro to be on the top. I expected this mostly to be CatchyOS, but like basically distros that are based on other distros.
Upon which 4 distros shone above the rest: Fedora, CatchyOS, Arch, and Bazzite. As somebody who kind of likes going fast, I was immediately drawn to CatchyOS. It's a version of one of the main Linux distros called Arch. Yep, but what makes CatchyOS interesting is how much faster it is than pretty much anything else.
Is it? Like, seriously?
And I'm not talking like, oh, it's less bloated or there's faster animations. No, I'm talking
Okay. 4K. So this is a benchmark. And CatchyOS. So it is faster by 8 frames when it comes to compared to Fedora and then to Ubuntu. By the way, why Ubuntu 25? Why not stable? And here it's like 100% slower. I would like to know what kernel they were running, because I don't think they were all running the same kernel. That would be my assumption.
Optimizations that can legitimately yield double-digit speedups. There was even a dude in my Twitter replies saying that Counter-Strike gets more FPS in CatchyOS than in Windows. Linux? Better for gaming? Huh? And while we're on the topic of gaming, it's hard to ignore Bazzite, a derivative of Fedora that's built for gaming and tries to mimic the Steam Deck experience with GPU drivers and Steam Big Picture mode pre-installed. Bazzite honestly seems like a pretty sweet option, but it's not what I'm gonna use because it's designed as more of a managed experience where most of the operating system is read-only by default. And I know that sounds antithetical to like what you've heard about Linux being, oh, it's so customizable, but I promise it's actually a good thing, especially for noobs, because it's a lot harder to brick your shit. I just feel like I want maybe a little bit more of a traditional Linux experience, at least to start. And you need to get subscribed because you don't want to miss the follow-up to this video where I tell you about my experience in a month or so. Once I'm done, it's gonna be magical journey. CES is definitely not next week. Then there's Nobara Linux. This one was a little bit further down the list, number 9, but it's gonna blow your mind. It's gaming focused and based on Fedora, just like Bazzite, but it uses the performance optimized Linux kernel from CatchyOS. How is any normal person supposed to figure out what one to use? That was 4 of like hundreds of suggestions. Now I
am very curious, by the way, good freeze frame. I am very curious what actually those kernel patches are. Like, are they like affecting queuing system or something like that?
guess, Wendell. But we're gonna flip a coin. The heads is CachyOS, tails is Nobara. And I'm sorry, Allie, there's no distro called My Balls. Not yet.
Also, I am always kind of disappointed that most of these guys almost never use like plain OS distros. I kind of feel like those CachyOSs and Buzzites and stuff like that are something that will appear and go. Like the only distro that's based on another distro that I think will stick is SteamOS, because that has a very large backing behind it.
Look, it's a loonie. If you're unfamiliar, that's a Canadian dollar coin. It's called a loonie because there's a loon on there. That's tails, and if I get that, we're doing Nobara. And on the other side is Queen Elizabeth, and she's gonna represent CachyOS.
That coin is so worn out.
Oh, I don't want to move. I swear it's heads. I don't want you guys to think I bamboozled this shit, all right? I kind of want to do Cashy, so I might just flip this multiple times. CachyOS it is, baby.
Okay.
I don't know why I did that. But before we do that, we're gonna back up my systems just in case something goes wrong. And what better way to do that than by using the DH4300 Plus from Ugreen, who sponsored this portion of today's video. After you slide in up to 4 hard drives of your choosing with the DH4300 Plus, you can have up to 120 terabytes of raw storage to play with. That's enough to store thousands of
It's 2025. Why are 2 terabytes 3.5-inch drives still a thing that you can buy brand new?
movies and potentially millions of photos, even if you're reserving a drive for parity to protect your data. It's kind of like having your own personal cloud, but don't worry, the setup is easy enough that even someone with no experience can be up and running in just a few minutes. And you can do it by connecting your phone just by tapping NFC. In just a few more clicks, you can also be backing up your precious photos from your Android phone or your iPhone automatically. And it can even group your photos by person or by place without even having to upload any data to the cloud. That's all local, baby. Or in my case, taking full backups of my PC so I can nuke Windows without worrying. Cool, right? And it's fast too. With a wired connection, you can transfer at speeds up to 300 megabytes per second. That's astronomically faster than Google Drive will let me do, even with my multi-gigabit internet speed. And you keep control of your data in the process. Like all of their NASs, it can handle the whole family with a full permission system so that you can keep your personal data separate from the rest. It's just that easy, and it works remotely too. If you want even more protection, you can even back up your Ugreen NAS to a service like Google Drive or another Ugreen NAS automatically too. So even if you aren't trying Linux for the first time and you need a backup, why not solve your storage or photo woes with 15% off the new Ugreen DH4300 at the link down in the description.
To be honest, that looks pretty good. That's 3.8. Let's say, how much is that in my Polish currency? That's, to be honest, not that bad. I wonder if they do worldwide shipping, or can I buy this in EU to get my EU privilege when it comes to returns and warranty. Okay.
Let's download it. Oh, customizable, my favorite. That's not going to make this complicated. Ensuring a smooth and enjoyable computing experience every time you use it. You better not be lying to me, Cashy. You good human? I'm gonna not even look at that warning at the top of the page. Gonna ignore it. We're gonna push through.
Oh, that's actually interesting.
Be lying to me, Cashy. You good human?
You might not look at that, but I will. Select your preferred edition. Choose from a range. Oh shit. Oh boy. Yeah, like let's not go into this right now.
Not even look at that warning at the top of the page. Gonna ignore it. We're gonna push through. It's just like Windows. We have to make an install USB. They don't have like an install USB creator, so you download the ISO and then use a tool like Balena Etcher. And I'm gonna flash it to this SD card because it's faster than any of the USB drives I have, and I don't want to sit here and wait all day. And flash. Success!
Isn't it funny how it's easier to buy a well-performing SD card rather than USB pen drive?
But now what? Do I install it on my MacBook? No, actually, you can't. Now, there is a distro specifically for running Linux on Apple Silicon called Asahi Linux, and it does work on a ton of the older MacBooks. Anything M1 and M2 are pretty well supported. And if you go to the M4 specific support page, you can see TBA means that they haven't even started development.
Yeah, by the way, that's really good. Like, you can install that Linux on your MacBook. It's just that the most interesting features are not supported. And at least in my opinion, the most interesting features.
Well supported. And if you go to the M4 specific support page, you can see TBA means that they haven't even started development. So yeah, it's not going on my MacBook. Ooh. Instead, we're gonna install it on a Framework laptop. Now, if you're not familiar, Framework is a super cool company that builds devices that are designed to not only be repairable, but also upgradable. And you can see this one is so repairable and upgradable that it actually comes in parts. It's a DIY edition that you have to assemble, which is kind of freaking awesome. Not only that,
I mean, Framework is a good idea. I just think that, like, at least here in Poland, the prices are so ridiculously expensive for what you're getting. Well, in my opinion, like, Framework is a good idea that doesn't make sense at the current price tag they have now.
but you actually get to pick whatever parts you want, any RAM configuration, any SSD configuration. Hell, you can even pick your own RAM and SSD configuration and supply your own. In fact, I actually switched out the 1 terabyte SSD they sent me for a 4 terabyte SSD that I pulled out of the Framework desktop because I gotta be able to video edit on this thing. Oh God, oh God. Oh, I didn't think about this. Does the video editing software run on Linux?
By the way, Framework has a desktop? Didn't know about that.
I guess we'll find out. This thing it's a sword. I know we haven't even installed it yet, but the thing that has me worried more than anything is the battery life. I'm so used to using an ARM-based MacBook that's like crazy power efficient. But to go back to AMD is a little daunting. Let me just...
It's, truth to be honest, it's hard to go back when you get accustomed to Mac's battery life. It's simply amazing.
Swap the I/O. Ow! Fuck! We got a Ryzen AI 9 HX 370 with Radeon 890M graphics. Huzzah! CashieOS, let's go! Wendell would be so proud of me right now. Hey, look at that. Where's my mouse? Oh my God, it's so small. Launch installer, eh? Very nice. Oh my God. We haven't even started the installer and it's already...
Oh, yeah. I really like how some of those distros claim to provide a smooth experience, and then they always give you, as let's say a typical user, like a home user, ability to choose something you have no idea like how it works, what it is, and why you should be even able to choose it. Like, for most of people that are trying to use it at home or for gaming, this doesn't matter. Why are those distros making you even be able to choose it? Like, why are they like aggressively popping up and asking you about this? If I was an expert user, just give me the ability to change it later.
Asking me what to pick and giving me no information about which one I should pick, other than this one is the default. So hopefully that's not a problem later. Yo, I can install it with Z. I only got one disk. I'm probably not gonna do that. That seems like a lot of overhead.
Oh yeah, have I ever told you a story how I recently wiped 40 terabytes of data with BTRFS? That's a story for maybe another time.
There's so many options. Oh my God.
Yeah,
I don't know. I think I can change these after. I know GNOME. GNOME is like the OG, the default. Cosmic. Whoa, that looks like macOS. We can ask the internet. A lot of people are saying Plasma. Okay, well let's start with Plasma. Oh cool, I can pick other ones to install. Cosmic looked cool. I like the idea of that one. Maybe we'll try Hyperland because people kept yapping about that. Whew. That was stressful. I like how there's like a description of the
Hyperlink is
desktop
so annoying.
manager, but I feel like there should be a default. New users should probably use this one to start or download a couple, you know? While that installs, I guess it's time to do my desktop. Welcome to CashEOS. We, the CashEOS developers, hope that you will enjoy using CashEOS as much as we enjoy building it. The links below will help you get started with your new operating system, so enjoy the experience and don't hesitate to send us your feedback. The controls on the top work right off the bat. That's a good sign. That's a great sign. Installing packages is definitely one of the biggest hiccups when you get into Linux if you're used to Windows and macOS, because there's so many different types of Linux. Let's say you want to install Helium. It's a really cool open source browser. It's based on the Chromium project, which is the base of Google Chrome, but they basically just don't include any of Google's garbage, and it has ad blocking built in. If you're using ad blocking, just allow list my channel or YouTube Premium. This one, honestly, I think will work. If you're trying to install something, I don't know, more complicated or maybe like a smaller project, you might end up getting the instructions for, I don't know, how to install it on Ubuntu and Fedora, but nothing for how to install it on an Arch-based distribution like CashEOS. And the packages they give you might just not work. It might only be possible to get that application installed by building it from the source code. I've heard that
Which is terrible idea nowadays. Like building an app from scratch, like compiling it, is something you only want to do when you are very, very well aware of what you are actually doing.
Arch has gotten a lot better in recent years for that. And let's see, I mean, they have
Don't say AUR.
a lot of popular packages right here that I can just install. I made a list of like programs that I use every day, and I really need to see that all of them, or at least most of them, are supported. I think I'm liking this Plasma desktop environment. It's nice and snappy. This will start the program. If you don't trust it, click cancel. Continue. Hey, well that was easy. We got a torrent client. That's important. Handbrake. Oh, yeah.
Hey, you know what's amazing? Amazing thing. I fucking hate YouTube. Because I just noticed. Oh my god. Screw you, YouTube. Screw you, YouTube. I just noticed that I wasn't live on YouTube this whole time. I was unpublished. But don't worry, this will be available as a VOD. Ah, shit.
Yeah, I'll install Handbrake, sure, why not? LibreOffice, that's a good one to have. It's like an open source version of Microsoft's Office suite. But
Yeah, it's an open source office of the Office suite that works half of the time.
I mostly use Google Docs and like Google Sheets and stuff, so
That's
I
a
probably
good
don't need
alternative.
that. OBS, VLC is a great one for video playing. Whoa, it's cooking. Wow, that installed so fast.
Yeah, VLC. By the way, in my opinion, VLC kind of sucks. I tend to use MPV, and the reason is very trivial. Some time ago, there used to be this whole drama about whether people should use VLC or MPV because one, like, decodes colors better and gives like more vibrant or like more proper colors. But for me, the reason is very, very pragmatic. Whenever I'm switching in my anime from English to Japanese language track, in VLC, and no joking, it takes it like 2 or 3 seconds to switch, and the video freezes. In MPV, it takes like half a second, so it's instantaneous.
I'm used to like APT on Ubuntu or Debian, and it's like just takes its sweet time, but that was pretty quick. Is this just gonna work right off the bat? Let's try it. We do screen capture, Pipewire. I don't know what that is, but sure. Hey, look at that. Okay, I don't have audio. How do I get video acceleration in OBS?
That's a
Can I
great
just
question,
go
to be
the
honest. I
AMD
have no
website?
idea.
I don't think that's how that works. It was there the whole time. I just didn't look at the right thing. Oh, I can look up repositories. We're cooking on this Linux. All right, you're here, boys. There's definitely a lot of packages in here.
Like there are
Wow.
custom
Let me
Arch
try like some
repositories
other stuff for my list.
of Helium. Interesting.
What about a 10 gig dongle? Is that just gonna work? Dude, it's working. 10 gigabit. Okay. One of the cool things with Linux is that a ton of the drivers for so many different devices are baked into the Linux kernel. For a lot of things, you don't even need to go in and install drivers. They're just there. I mean, Windows has a ton by default, but Windows doesn't have one for this 10 gig dongle by default. Okay, this is going honestly pretty well so far. I've got a web browser installed. I'm gonna have Steam installed in a second here. Not that I ever game on my laptop, but I sure as shit wanna try. Hey, there we go. Steam's working. Sick. I don't actually play a ton of different games, but there is still problems with anti-cheat in games not supporting Linux properly. If I recall correctly, Faceit for Counter-Strike, their anti-cheat doesn't support Linux, but scrolling through my Steam library, it seems like...
I mean, that's also something that doesn't necessarily surprise me. Like, in order to properly anti-cheat, you basically need to be very deep into the system with kernel level anti-cheats. Like, sorry, but from what I've heard, the level, like the things people do in order to cheat are just so amazing nowadays. So
most of the games are in here. I don't see any that are like super obvious jumping out at me as not allowed. Baldur's Gate is in here. Arc Raiders, they'll all install. Here is maybe a deal breaker thing for me. I gotta be able to video edit on the go. That's why I picked a higher spec laptop, and I normally use DaVinci Resolve. It's really awesome editing suite. We love that stuff. Oh, cool. Wow, they have like all the driver information and whatnot. I'm noticing a distinct lack of DaVinci Resolve launching. We might need to do the terminal install. DaVinci Resolve run -I. App images require Fuse to run. Let's try to get Fuse. Hey! I don't know why there was no prompt to say that it needed Fuse to work. We got DaVinci, baby! There's so much Linuxing happening! Okay, Resolve is not launching. I feel like I'm missing dependencies. Look at that, we're missing...
yeah, I'm sorry, you installed the Linux for gaming. This is not Linux for work. You need to install a whole another distribution for that.
libpango. On the Arch Wiki, there's a whole thing on how to fix this specific error we have. Okay, cool. Now will it start?
Yeah, like I would say this is Linux in a nutshell. Not necessarily that you have to Google for stuff. It's just that providing software for Linux is such a terrible thing to do. Like if you were to support your software across all of the distributions, I'm pretty sure you would die.
Yes! Success! You know what? I don't actually know how to install a package on Arch. How to install package from AUR.
No,
Arch.
don't do
Uppercase S
AUR.
to do it. Oh, it's building it from source. That's so cool. DaVinci has still not started. I'm having a great time right now. It's been 30 minutes of trying to install one program. Holy shit. Oh god. I don't know what it's doing. It just says checking licenses. Use license key. Oh my god, it's working. It seems like if I launch it not from the terminal, it doesn't work. But if I launch...
To be honest, I haven't ever tried DaVinci on Arch Linux. I did have like I think, or maybe I have tried it on Vanilla Arch to do some simple stuff. But yeah,
launch it from the terminal, it's fine.
Like desktop shortcuts on Linux desktop is whole another level of, I would say, just one bad idea after another.
This is miserable so far. Boy, I feel like I have lived 100 years in the last 4 hours. It's been most of the software items in my list just downloaded and worked. I've got my text editor, I've got a web browser, got my SSH client, I got my coding stuff, Discord, Steam. Hell, even right now, I installed CachyOS on my desktop. I'll have links to a spec out of my workstation in the description, as well as a link for the Framework laptop and, I don't know, MacBook, I guess, if you want one of those after watching this video. As for DaVinci Resolve, it loads, I was able to get a new project created and imported footage into it just fine and did some cutting around and it seemed to be working. However, anytime I tried to load an existing project that, you know, like a finished video, it just crashes. There is a ton of different information on the Arch Wiki on how to like optimize DaVinci, but for now, you're just gonna have to stay tuned for the update video and see if I was even able to get it to work. So
Imagine just being like wanting to just install a new source software instead of troubleshooting it during installation. It feels like we are like Windows was at this point, I want to say 20 years ago.
get subscribed so you don't miss that. I did have one other major issue. Fusion 360, the CAD program I like to use when I'm designing 3D models and whatnot, it doesn't support Linux. There is supposedly a way to run it with an app called Bottles. It allows running Windows apps in Linux, but I tried that for a good hour messing about with the various different configurations in it, and I wasn't able to get it working consistently. I gotta figure that out. Or I could just play video games for the next month. I'm running a game right now, Borderlands 4, from the output of my desktop upstairs using a GLI Net KVM. And not only am I running Borderlands 4, well, I'm not gonna say well because it's Borderlands.
So he's running the game from his desktop on which he also supposedly installed CachyOS. Okay.
4, and it just doesn't run well, even on a 5090, but it's running and not crashing. But I'm also running Sunshine, a game streaming server, and its companion client, Moonlight, on the Framework Laptop 13 here. So my desktop upstairs is now running Linux. It's streaming a game to the laptop that's running Linux. Oh my God, compiling shaders. Oh, I'm not gonna lie. I was expecting the software side of things to be the easy part and the games to be the nightmare, but all of the games I've tried, Overwatch 2, Arc Raiders, Helldivers, Borderlands 4, they all...
The difference is that the software part he had problems with is managed by quite possibly either a community or the people that manage the distro and package stuff. The games, the abstraction layer, the compatibility layer is managed by people who get paid for that on Steam. That's the big difference.
I'll just... What is happening? Is that artifacting or is that just anti-aliasing? Yeah, I don't... But is that just the game running like crap? I don't know. It might still be dumpster trash. I'm not entirely sure. Borderlands is an important one because I'm doing a Borderlands playthrough with the wife, and if I couldn't play it for a month, I might get murdered. So, holy shit. When I'm playing Overwatch on Windows in the same settings, I get like 400 to 500 FPS. In Linux, 500 FPS! Like 400 to 500 FPS is the same performance I get in Windows. This might even be better. I'm not gonna go like crazy in depth on like exact performance testing in this video. Stay tuned for the 30-day update. I'll run a bunch of benchmarks in all the games I play in that video, and we'll get to see like really what it was like, and not only just the performance, but also like how stable it was and how reliable this whole setup was. But I'm impressed. Genuinely. Will Battlefield even run? No! Damn it! Am I allowed to run a Windows VM on this planet with the automatons? 150 FPS.
Well,
and not only am I getting that FPS in the game, but I'm also game streaming at 100 megabit to the laptop and recording locally on that machine also with the GPUs. I mean, the 5090 is no joke, but like, I was expecting it to be a lot worse. Maybe this isn't gonna be that bad. Maybe it's gonna be okay. Maybe using Linux is not gonna be the worst thing that's ever happened to me in my entire life. Never mind, this is horrible. I'm getting my shit rocked and it's all Linux's fault. Holy shit, there's so many, ow! Thanks for watching. If you like this video, you hit the like button, get subscribed.
Yeah, definitely.
And honestly, let me know down in the comments what Linux distro you would use. Did I pick the right one? It seems to be working pretty good for me. Let's just hope that this isn't the worst month of my life.
Try Linux earnestly. Do something interesting with it.
Well, it's a good video. I mean, the intro, I would say, and the title is kind of clickbaity, but okay, it's a challenge. We'll see how that goes in 30 days. I wonder whether he'll hit the same problems I've had, which kind of made me say this gaming on Linux thing kind of sucks. And it sucks for somebody who's not tech savvy. Not because you have to sometimes debug or not debug or stuff like that. It's because unless you are very like specific in what you want to achieve and you actually know how to do it, and you are like willing to basically do to basically install like different tools for different games. Like you can run some games on Steam natively, you can run some games on with bottles, you can run some games with Lutris, you can run some games, and that's, you know, if you are willing to do that, then sure. But if you are like looking for streamlined experience, then oh my gosh. And the one feature that I've hit that made me say this is shit, to be honest, is that your experience playing on Linux with Steam may vary depending on how you installed the Steam. If you went the easy way and installed it with Flatpak, the funny thing is the native games for Linux that you can buy on Steam typically do not work. But everything else that is being handled by Proton works. And for me, that was super weird. But yeah, overall good video. I need to check out this NAS thing. Right now I only have like, I want to say Pocket for discs. So I basically plug into 3.5-inch drives and have them visible on my server, and then I do with them what I want directly. But this actually looks pretty interesting. Okay. This one looked interesting and I haven't seen it yet.
If I were a shovel manufacturer during the gold rush, what sort of shovel would I build for myself? Well, that's exactly the question that I'm answering today as we tour the NIX supercomputer at NVIDIA headquarters here in Santa Clara. Behind this door are 1,192 B200 GPUs, absolute monsters rated for up to 1,200 watts of power each.
We have 20 of those in our data center that are not ours, are co-located, but still it's nice. It's nice to have them at the reach of your hand.
And they've been used for everything from AI research to DLSS upscaling for gamers to good old-fashioned MLPerf drag racing. You know, to put the other AI upstarts in their place. So what are we waiting for? Let's gear up and get inside. Oh, shoot, what was the password again? Oh, that's right. SEGUE for our sponsor.
MSI. Their Crosshair A16HX AI is an 18-inch high-end gaming laptop that comes with a 50 series card and a 240 Hz display. Experience smooth gaming on the go with the link in the video description.
Are you tired of boring screwdrivers? Boom! 4 new colors of the brand new LTT transparent screwdriver. Plasma purple, cryo teal, molten orange, and carbon black. They're see-through, they're awesome, and they're probably gonna sell out. Because for a limited time only, if you buy through YouTube Shopping at the link in the video description, you will get 20% off your driver, but only until December 30th. Collect them all, or maybe pair them with our brand new bid case and all over print hoodie. This particular data center space is used for a combination of R&D and NVIDIA internal production, meaning that it gets reconfigured on a pretty regular basis as NVIDIA works through validation of new chip or server designs. That's
a super clean data center. Like, I know that some people that work in the data center I work at say that ours is messy and dirty. It's not. But this one is sparkly clean.
That's why the raised floor has these plumbing access hatches for high-density water-cooled deployments, even though at the moment it's set up for air cooling to accommodate the DGX B200 racks that currently line the floor. We're in the first of 2 rooms that are linked by this fiber optic...
Yeah, so probably he talked about raised flooring. But yeah, like, even if you have like fully water-cooled data center, there is almost always some residual air air heat being exhausted from the servers, because very little like servers have solutions to be 100% water cooled and be fully neutral to the server room. So you almost always need to have some sort of traditional cooling for the data center room.
DGX B200 racks that currently line the floor. We're in the first of 2 rooms that are linked by this fiber optic cabling, each of which contains 2 CACs, or cold air containment units. We're going to go in one of them in a second, but before we do, I want to talk a little bit about some of the details that would be easy to miss in here, like this decibel meter here that probably illustrates why it's better for us to talk out here. The deployment is absolutely peppered with sensors.
Oh yeah, by the way, AirPods noise cancelling, like I didn't like when I started working now in my data center at ICM, I didn't have no noise cancelling earphones for like 2 or 3 years, but then I bought AirPods and that changed my life forever.
Obvious ones, like temperature on both sides of the rack, like this one right here, and also less obvious ones, like humidity and air pressure. Humidity management
Okay, airflow sensors are pretty cool.
is very important. Too low, and static electricity becomes a problem. Too high, and your servers start to sweat. And then you're gonna start to sweat. Air pressure, or maybe more accurately, airflow, comes down to cooling. The DGX B200 systems here are, of course, equipped with their own cooling fans, and the same goes for the accompanying InfiniBand fabric networking equipment. But for we are talking about up to 14,000 watts of power consumption in each of these units. Huh, just to say that these fans can use all the help that they can get. So fresh air gets actively
Yeah, interesting. So they have like all of this flooring. They do not have like any in-rows that blow the air sideways. What I am most surprised to see is that those servers are fully air-cooled.
blown up through the floor, creating positive pressure inside this room, where it gets pushed through our DGXs and out into the hot aisle, where things definitely get a lot hotter. I mean, I was getting kind of chilly in there, but here I would be sweating in a matter of minutes. But in spite of the challenges, the systems are running perfectly, and NVIDIA pointed out that some of these nodes are running full tilt on undisclosed workloads as we speak. Now, because NVIDIA uses spaces like these for validation, it's important that they get all the little details right, so customers can just take this blueprint, copy it, and paste it into their own facility and trust that it's going to run at scale. The networking racks, for instance, are strategically positioned to minimize the length of fiber optic cabling between the 4 CACs that make up this cluster.
Yep.
2 in this room and 2 in the next one over. This is both to maintain signal integrity. They found any higher than 100 to 150 meters can be problematic at these speeds. But it's also to maintain the integrity of the ceiling. See, it turns out that when you start bundling up hundreds of fiber optic cables, they can get pretty heavy. And the longer the runs, the more strain they put on the ceiling. It also helps save on cost. This I don't have.
Yeah, that's interesting about the ceiling. I didn't ever, I think, came upon problem like that. But yeah, the interesting thing here is that you actually very often take into consideration the how long your cables will be when you are designing a supercomputer like that, which is like you are basically achieving 2 very simple things here. First of all, you are optimizing the costs, because those cables in those quantities cost a lot of money. And the second thing is, like Linus mentioned, the signal quality. It turns out if you are like having 800 or faster, 400, 800 links for interconnect, it turns out you cannot just like run them indefinitely. Like latency is a whole other thing, right? But the signal quality matters very, very much. They are using InfiniBand, so it probably, like, depending on what technology you will use for interconnect, InfiniBand, Rocky V2, or something else, you might get different like requirements when it comes to that. But still, yeah, that's totally a thing.
Much to say about other than, oh my God, isn't it beautiful?
It is.
Okay, I lied. I do have some stuff to say. This cable management is not just for looks, but rather to maintain airflow. When you have this many cables, you actually do need to bundle them. And it also helps facilitate maintenance. In the event of a broken or damaged cable, they run extra fiber in each bundle that can be terminated as needed. And it is a lot easier to find that when things are organized. Careful thought goes into rack serviceability too. While the networking racks use traditional vertical PDUs for their power distribution, the DGX racks use 3 top-mounted PDUs that help balance the 3 phases of power coming in. On the subject of power...
Yeah, I've also seen that. With the recent racks we have gotten into our data center, it's also because if you have water cooling, I don't think they have water cooling here, but in the case I saw, it's that when you have water cooling, right here you have manifolds from which you connect the water hoses to the servers from the manifold. Then the manifold goes into an exchanger at the very bottom of the rack. So if you have those manifolds on the sides of the rack, you have nowhere else to put the PDUs. So it's the best possible solution to this problem.
In. On the subject of power, we skipped over these at the SFU data center, but have you ever wondered what a
415 volt, 100 amp
power plug looks like? Wonder no longer. Another key advantage of putting all the PDUs up top is it makes it a little easier to get the DGX units in and out. They turned this one off and agreed to pull it out of the deployment just to show us how it's done, but
oh my God, I love this
when I asked if we could tear it down, they were like, huh? Not because they have anything to hide, but just because they thought this soon-to-be decommissioned and recycled engineering unit that we can really get our greasy meat mitts into would be a lot more.
Please give me that decommissioned unit if you don't have any need for it. By the way, this is how much you need in terms of airflow and heat exchangers in order to cool a system like that with air alone.
Or fun.
And to be honest, I am very surprised that NVIDIA in their own data center uses mostly those. I mean, I kind of get why. Okay, doing custom water cooling requires you to do some custom plating on the motherboard to properly cover the chips, which is, I would imagine, a bit more costly and custom especially if you are running R&D, but still, why not water cooled?
If you ever wondered what the heatsink would look like on a 1200 watt GPU, wonder no more. How many heat pipes is this? It's like a forest of heat pipes in there. Oh, they're flat. That makes so much sense because you'll get more airflow through the fins. And I mean, that's some pretty hard-working air dealing with not 1, but 2 rows of these GPUs. Not to mention this middle heatsink here that seems to be for the NVLink switching equipment. I mean, I knew you need some beefy
cooling
to allow these GPUs to pool the 192 gigs of HBM3E memory that they have, but still, I'd never seen the cooling for it. Another thing I've never gotten to see, or at least never gotten to film, is NVIDIA's proprietary SXM interface. I know because I was looking for a B-roll shot of one of these a little while ago, and I realized I've never actually held one up on camera. So now I've done it. And they also gave us this to show what, okay, not the same generation, but a similar GPU might look like without the heatsink. Oh, we've also got to look at the SXM interface that goes back to the rest of the system and also carries power for these GPUs. These are 1200 watts each, but these cards go as high as 1400 watts. I mean, how high would the cooler be at that point? JK, it would be water cooled. We were hoping to see some water cooled machines today, but I guess NVIDIA has to save something for next time. I gotta say though, if the new stuff is even just equally cool to the last gen H100 water cooled machines we saw at the SFU FUR supercomputer, I'm sure it's absolutely mind blowing. All of which is really cool, but what do they need all of this for? Well, the folks who are responsible for getting us access to everything today are actually from the GeForce Gaming team. So one of their big uses for these internal compute resources is, of course, Deep Learning Supersampling, or DLSS. In a nutshell, DLSS allows your GPU to render your game at a lower resolution, then use deep learning, or AI, to upscale each output frame to your monitor's resolution. The benefit of this is that you can run at a higher frame rate for improved animation smoothness, but the drawback is that you can't create something from nothing, and upscaled images struggle to achieve the same fidelity as a native rendered image. With that said, DLSS
Yeah, that's why I don't want to say I'm very big. Okay, so DLSS in gaming is fine. But whenever somebody tries to apply this logic and, for example, upscale movies or TV series or something, this is where I want to say, draw the line, because AI can make something look good, but when it comes to the details, you basically cannot create information out of nothing. Like, you cannot the algorithms can't really come up with anything the way we do. So very often, like, the thing I'm afraid of is that we will come to a point where everything is AI upscaled, and we will lose that original, the originals that they were upscaled from, which is like a very niche thing to fear. But, as somebody who kind of like at least tries to hoard some audio and video, and I have been into encoding, I'm not really that big into it right now, what I used to be. I am kind of afraid of that thing happening.
DLSS has improved a lot over the years, and I got a chance to sit down and chat with Edward Liu from that team, who talked us through some of the processes that they use to develop new features and new fixes. The first thing he pointed out is that while this hot new AI model took 1,000 GPUs 2 weeks to train, or whatever, makes for a good headline, it overlooks most of the actual cost and time, which is in the test training runs that take place before the hero run. His team is constantly iterating on the data they're feeding into DLSS and the weighting, and they're evaluating new innovations in the AI space. Sometimes it's more surgical, like, oh hey, we noticed.
To be honest, I forgot that DLSS has to use its own custom AI model that's trained. Now I wonder, how big is that model? What kind of model is it? How does that work?
Cyberpunk has an issue with cars having like 3 or 4 bumpers as you're driving around. How can we address this with the current model? That kind of thing can be turned around sometimes in a matter of weeks or months using the resources that we just saw. Though, he was quick to point out that, Jensen, if you're watching, there's no limit to how many GPUs his team could use to speed up the process. I told him I'd say that, because the faster they can test a new data set, the faster they can tune it and ship it. Other times, the changes are more transformative, pun intended, like the move from a convolutional neural network to the more accurate transformer model that runs best on NVIDIA's newest cards. This can require basically a complete teardown and do-over of the entire pipeline and can take a year or more. But, I mean, hey, NVIDIA has bet pretty much their entire future on being able to stay at the forefront of their 21st century shovel technology, so I guess that's the price you pay. But what does all of this mean for traditional rendering? Well, the folks here believe very strongly that in time, DLSS will not only be as good, it will be better than traditional. In fact, Edward pointed to these slides from a talk that he gave a number of years ago, showing that what we think of as native rendering is already a pretty imperfect approximation. Here it is compared to a ground truth image, which is rendered at a much higher resolution than downsampled to 1080p. Native? It's clearly worse. And as you can see in this comparison, even back then with DLSS 2.0, there were situations where a model trained on these higher resolution.
Oh, somebody subscribed. Hey, thanks. Oh, hey, Natalie.
Or more accurately, higher sampled ground truth images could result in the GPU reconstructing an output with DLSS that's closer to ground truth than the native image was. I asked, by the way, how are these ground truth images created? And he said that typically it's actually just on run-of-the-mill gaming hardware. But instead of running at 60 or 120 frames per second, they'll sometimes be running tens or thousands of pixel samples to the point where we're talking more like 60 to 100.
What's up? So I'm watching some YouTube tech videos. This is like the second one, but the next one is where I will appear as a guest. So we'll see how that went for me in 2 minutes.
120 seconds per frame, or even more. Man, though, if DLSS could consistently reconstruct that ground truth image from a lower resolution input every time, I'm sure no one would ever turn it off. Unfortunately for Edward and his team, though, no one notices when DLSS is working perfectly. It's when it trips over itself that we tend to notice, and it still does do so fairly regularly. However, with that said, from my own experience, it has continued to improve at a pretty solid clip since its debut, and the rest of the industry has pretty much accepted that AI accelerated image enhancement is the future, whether every gamer wants it or not. So, sales of shovels will likely continue until gamer morale improves. Good luck, everyone. I hope it's not a bubble. This is a nice office. I'd hate for something to happen to it.
No, I'm not.
Just like this is a nice segue to our sponsor.
Squarespace. If you're building a brand or a business, it's important to have a website. Designing your own site can feel like a bit of a daunting task. See 10% off.
Overall, really good video. Like Linus gets a like from me. And oh shit, an actually comprehensive and a good data center overview with some good examples of what they are using it for.
I don't know.
Yeah, like
Trim.
I mean, I wish I had
Oh,
like
they're
data
flat.
center
It's like humidity.
clean like
PGX
that.
P2.
Like, geez, those, like, I want to say you can eat from those. Do you want to be? No, thank you.
200 racks
and
that
those
currently
fibers
line
are
the floor.
so
We're in the
cleanly
first of
laid.
2 rooms that are linked by this fiber optic
Like,
cabling. Each of
and there are so many of them. Like, I wish I had that rich of like patching panels in my data center. But yeah, that's Linus' video done, and let's go to our main thing for the evening.
Everything else going on at Supercompute 25 was interesting. You have to understand this is an academic gathering. It's been subsumed by everything AI, sure, but the academics that I met here were excited because even if we're in an AI bubble, we've built all this compute. And I trust the AI academics to come up with interesting uses for all of this compute for everything outside of AI, scientific compute, research, you name it. First up, AMD was showing off their plan for Helios. That's the name, that's the plan for their open compute.
So, by the way, just as a word of intro, I was at the SC25 and I actually spent like 2 weeks there helping building it. And it turned out that because this was like my 5th year doing SC, this is the first time when I saw, I want to say, YouTube influencers just attending. And the funny thing is, like, it's not like I saw just Wendell or somebody else. There was, like, I want to say, a mass of YouTube people actually at SC this year. I'm not sure if it's thanks to the location. Maybe they are just like digging St. Louis, or St. Louis is close to everyone. I have no idea why, but maybe. But yeah. So like I said, I was there. I like walked the hell off my feet just walking that showroom floor.
Compute rack scale AI infrastructure. It's a double wide rack. It's sort of a new rack design, but this is how they're going to build it.
Helios, AMD Helios. And they've got kind of a demo, kind of an interactive thing, but I want you to notice some things when I pull out the drawer. First off, look at all those memory channels. Look at that. There's 16 memory channels on this platform. That's interesting. I mean, it could be 8 memory channels with 2 DIMMs per channel, but really, we know. But also the networking fabric. This Ultra Ethernet stuff is one of the most interesting aspects as we look at, sort of.
Oh yeah, Ultra Ethernet. Yes, that's super interesting.
The whole ecosystem solution that AMD is building. We know MI400. We expect MI400.
So by the way, Ultra Ethernet is because there is something called interconnect, and there are different technologies basically doing interconnect. And interconnect is a type of a network that allows you to do remote direct memory access. So if you have like multiple servers in a rack, you can basically configure them to kind of have a unified memory space across different servers. So your program basically thinks it is like on a single server that's bigger. And interconnect allows that. And there are different ways of doing interconnect. There's like InfiniBand, there's like Slingshot, there's like Aries, there's like Rocky V2. And the problem with that is that almost all of those technologies are proprietary. So for example, NVIDIA, after they bought Mellanox, they are big into InfiniBand. I think HPE has Slingshot, I think. Don't quote me on that. Rocky V2 is like an open standard, but it has its own problems because it uses like an actual Ethernet to work. But Ultra Ethernet, and they always, I don't know, somehow manage to pick the worst, most confusing name scheme ever. Don't want to say nothing to do with the Ethernet, but Ultra Ethernet is the new interconnect thing that will be open, will not be proprietary, and will be built based on the experience we've got by doing Ethernet for such a long time. But you will not be able to transmit the traditional or legacy Ethernet frames on it, right? But it's a very cool thing that just so recently has started to, I don't want to say appear, because they only just recently started, I want to say, having an like very first draft of the standard, and they are like accepting discussions and requests and changes, and they are still working on it. So it's a very much work in progress, which is very interesting thing to look out for, especially if you are big into HPC, AI, or data centers.
To be amazing when it comes to performance and inferencing and everything else. AMD has to be showing this to partners, and this has to be what's driving some of the partner investment interest stuff that we see, sure. But that's not the whole story. The whole story is connecting everything together, running it, and building that with a software stack. We get a little preview of that with some of the updates to ROCm and everything else that's going into that. But I think the most interesting pieces here are the memory bandwidth. Look, it's a single socket in each one of these drawers, and yet, it looks like there's 8 interconnects here, plus also the new stuff that we look at from the fabric, Polara and Pensando, and the networking aspect of this. There's a lot of interesting little details you can notice here, some of which have been hinted at, some of which have been announced, and some of which are not yet on everyone's radar. But the details are there if you look for them. For Instinct, there's your processor. That's a lot of memory channels. Notice the memory channels. But your network interfaces are here. Volcano AI NICs, PCIe Gen 6 and UA Link. Instinct GPUs, MI450, CDNA up to 432 gigs of HBM4 per GPU. And then here is your fabric interface. Ultra Accelerator Link over Ethernet. 72 GPUs in a rack. So your compute and GPUs, and then your fabric interface, the other side of the 16 interfaces we just saw coming in here. Everything is connected to everything else, because that's how you have to do it.
To be honest, that visualization is kind of confusing to me. Like, I would have to basically stare at it for 15 minutes to actually understand how this is like situated and positioned in the rack.
And this is in that double width open compute standard, so,
Okay.
Delivered and configured as a unit, I'm sure.
That makes more sense. Yes.
I'm at Gigabyte. I'm with Liam. Remember Liam? He's in all the videos. there's a lot of cloud stuff happening here. Look at that, it's the NVIDIA partner badge somewhere here. But this is not NVIDIA, this has nothing to do with NVIDIA. This is actually Ampere. This is their 1U platform. You can do inferencing with it. You know, we can make it about AI. But I think that relegating Ampere to just AI and inferencing, they've got a lot of opportunity. This is a neat platform.
The simple 1U, Ampere 1M processor up to 192 cores. It's very popular. They're starting to get into, you know, AI inference workloads because
192 cores.
they can handle, if it's like 10 billion parameters or less, they can handle on a CPU. You don't need to have a GPU.
Pretty
so
reasonable memory bandwidth for their platform.
Yep,
Pretty
yep.
reasonable connectivity.
Yeah, so this is a really exciting platform we've just introduced this year. We've got about 10 models that support the Ampere 1M series of processors, so it's pretty cool.
Yeah, it is really nice to see good performance and good release cadence from Ampere. And so it's always nice to see partners supporting Ampere for that kind of thing, because some companies are all about ARM. Some companies are all about density and deploying things. And I think I found my new multi-node game server. So this is what is like a multi-blade chassis? Like what do you call it?
Yeah, it's our first Blade series. We have the new B series we've introduced.
By the way, to be honest, still ARM isn't as popular in the data center or in the academic space, at least in Poland, as I thought it would get.
And this is a 10U, it's a 3U 10-blade server that supports the EPYC 4005 CPU, but we also support the LGA 1700 Xeon.
Look, it's my beautiful, beautiful AM5 socket. So this can run your Minecraft server with multiple M.2 ports. You have dual memory channel. You've even got some PCIe connectivity here. You wouldn't run a GPU in this, but you could run high-speed connectivity. This would make a fantastic Linux box, cPanel servers, this kind of thing. This is the kind of thing and the kind of density that we see like the medium and large hyperscalers replacing. But you know, in terms of like 10 node for like a small business Proxmox server, this would also make a pretty reasonable platform for that use case. And so it's,
I mean, as a platform, yeah, as a form factor, I don't know. But sure, if you are like small to medium size, I want to say cloud provider, great.
it's nice to see more enterprise engineering go into something like that. Gigabyte's gone a little off script. This is actually 2 AM5 sockets on a single PCB. This is 2 systems in one drawer. Each system has a dual 25 gig interface, so we have 4 25 gig interfaces in one of the blades. There's not any interconnectedness or, you know, failover or anything like that. You're handling all that in software, but you can do that on a 50 gig fabric.
Yeah, so that's what's pretty cool about this. It's again the same 3U size chassis, but now we're doubling the amount of sockets that we can support. Because yeah, we're using liquid cooling, and inside we have an inner manifold, so it kind of simplifies it. So, you know.
By the way, this is something I see, and on, I don't know, some previous SC, one guy who was standing next to me pointed out that if you have like dual CPU layout like here, and they are connected like so you basically have your input from the top, your exhaust also from the top, like doesn't matter, it can be like on the bottom, right? But basically if your loop goes like this, like the water goes to the first CPU and then it goes to the second CPU and only then it goes back, like the loop basically has one of those CPUs as the first CPU, then basically the other CPU will have will be worse off cooling, will not be cooled as well as the first CPU, and that means it will not be able to boost as effectively as the first one. Like this is only something I've heard as a note when we were being shown a presentation like this, but it's always like stuck with me as an interesting thing to notice.
When the liquid's coming in, you just have one liquid of cool liquid coming in, one warm going out. So you don't need to have 10 tubes of cold and 10 of hot. So it's pretty cool that they've simplified the design. And we'll see more of this product later this year, probably towards the second half, early Q.
AM5 in this kind of custom design. Someone is spending a lot of money to do custom AM5 design. That should tell you what the market demand is. It's kind of nuts to see something like this.
Yeah, this originated out of demand. It was
and also 25 gig network interfaces like screams to me like this is a highly dense cloud system.
particular demand by somebody, and that's why we've developed it.
Who could be replacing lots of sockets with lots of AM5 sockets? I wonder. This is Gigabyte's RTX Pro 6000 chassis. 6 RTX Pro 6000s in a traditional rack configuration. By default, each card's running at 300 watts, and there's also a Bluefield 3 DPU on the end there. This is what one of Gigabyte's GB300 NVL72 trays looks like. It's all liquid cooled and copper interconnects with 8 E1 flash storage bays in the front. NVIDIA controls a lot of the aspects of the design here, so this doesn't look a lot different than all the other GB300 NVL72s, but that's kind of the idea. But for x86, the Gigapods, Gigabyte has more flexibility. Side by side, the AMD solution with direct liquid cooling and the NVIDIA solution also with direct liquid cooling. Gigabyte Gigapods, which this is something interesting that I'm keeping an eye on. I mean, check this out. DDR5 DIMM throttling, not here. They've already preemptively built in heat sinks for the DIMMs. Modular, reusable, liquid cooling technology. And if you look, these two racks, there's really not a lot of difference in the liquid cooling infrastructure.
Yeah, I think you can see, I think the pink things are the pads for DDRs.
Between the sides, so we're supporting two completely different.
But basically, you have like a DIMM put in between those, and those like this pink material basically makes sure that it's padding the space between the memory stick and the cooling pipe, the copper pipe. So that's also quite interesting piece of technology.
Different AI universes with a lot of reusable parts. Love to see that kind of engineering. This is awesome. So what do you do when you deploy your data center, but then the utility company can't get you electricity in time? Well, you can deploy a turbine. I mean, it's a lot easier to transport natural gas or diesel or whatever. Mitsubishi has their M501G gas turbine. Not even joking, like this is part of the reason, this kind of thing is part of the reason why there's a shortage of turbines in America, because this makes it easy.
Okay, so now I get why Wendell said this and why he asked me about jet turbines when it comes to power, because to be honest, I haven't noticed it. Like the SC, the conference is so big, it's so like extraordinary big that it's almost impossible to see what everybody has on the exhibition. And that's only the exhibition, because there is also like lectures and student posters and like another floor above us with another like round of SC stuff going on. So
easy to put power wherever you need it. So it's like, we've got everything, we got connectivity, we just can't get quite enough power to scale as quickly as we want. This solves the problem. I'm always looking for new technologies that let me move PCIe devices farther away from compute. And NEC was showing off a really cool demo where the GPU from over here behind 2 kilometers of fiber is connected to this system, and it doesn't know.
yeah, by the way, this is a 2 kilometer of fiber spool. It's not that big.
The PCIe fabric is sort of handled transparently. The PCIe frames are going over Ethernet, but it doesn't know. This is the Network Operations Center for the Network Operations Center. What do you do when you're at Supercomputant's academic?
Who's this guy? Who's this guy? It's me. So maybe a quick bit of introduction, like quick word of introduction. So, by the way, yes, this is a typo in my name, but whatever. So I actually met Wendell when I was like just walking outside of the exhibition area, and I was like, "Hey, do you want to maybe go and come and see this thing?" It was like a day before, and he was like, yeah, he was actually interested. We exchanged emails. And who's that guy? That's me. And we exchanged emails. And we've kind of like tried to make some time slot for the next day. I really like wanted to be like able to show up for that time we wanted to meet. But I had a meeting that I had to attend where we assigned, we're basically discussing how to actually start tearing down the thing you see behind us. Because the very next day, we were starting to turn down this conference and basically unmount every piece on the stage. So we really like had to make this work. And funny thing is, Wendell kind of got lost. Because, and this is something that I'm kind of trying to fix, almost nobody knows what the hell is SciNet and where it is, and they don't even know that it's happening at the conference. Like everybody just sees the exhibitors, the booths, the big names like Nvidia, Gigabyte, Intel, AMD, whatever, and they don't even know that this thing is here, it's operating, and it's breaking some amazing records when it comes to internet speed and networking and stuff like that.
Academic research, and you need 1.6 terabits back to Oak Ridge, and some other people have their 800 gig and their 1.6 terabit connections, 10 gig distribution. I'm here with Bart. He's here to explain everything.
Hey everyone, my name is Bartosz Drogosiewicz. I represent the University of Warsaw ICM in Poland. So today with Wendell, I will be explaining.
By the way, the only reason I said this full thing, that I represent the random Polish university, is because, and this is like a problem for many people that do sign it, because this is basically a volunteer. So your university sends you to do this as like you are a volunteer, but basically your university sponsors you. So I only said that because I really wanted something to show off in my report when I came back. So it's not like I wanted to dab on somebody, because I really wanted to promote myself. I would say, hey, I'm DC Tech and I have a YouTube channel. But I really wanted to highlight. And I think that in the end it came out really, really funny, because what this is basically saying that, hey, I'm a Polish guy from Poland, from Polish university, and I will explain this amazing American initiative to you.
Explaining to you how this network actually works, and I will try to get into as much nook and crannies I can in my allotted time I have.
Scientists like to go fast. There's so much fiber.
It's so much fiber. So here currently we are at the main stage. This is so-called the main stage of the SciNet. SciNet is an organization that is responsible for building the world's fastest temporary network. We do this every year at this conference, and we make use of the equipment that vendors are donating to us. So not only equipment is donated, our time is also donated. We are volunteers that help build this network and make this conference happen.
And the scientists can run experiments while they're here to see, like, can we do quantum entanglement over the public switch fiber network?
That was actually the experiment last year, and
This that caught me really off guard, because I actually know the people and the team responsible for that experiment, and I completely wasn't expecting somebody to basically even be aware about that. But Wendell really took me by surprise here. Like, this whole thing basically took me by surprise, because I just wanted to, I wanted to be able to show them the SciNet. Then they hooked me up with a microphone and we just started recording. So, okay. But this guy knew about that specific experiment that last year other scientists from Poland were performing. And a funny and amazing story is that we actually kind of helped them perform that, because they had some small snafu happen. And just because we were just because me and my colleague were part of SciNet, we were able to help them make that experiment happen, which is a funny story, but I will save that for another time. But really, and later on, because we don't really talk about that much more in this chat, but I later introduced Wendell to the lead scientist responsible for that experiment that happened last year. So I hope that next year on SC26 in Chicago, we'll maybe be able to show it off, maybe work with Wendell, maybe work with other people who are interested, and be able to bring it, like show it to the larger audience. Like, that would be amazing. But really, I was really caught by surprise by how knowledgeable is Wendell, or basically into those things.
I can tell you a bit more about that later, but yes, we also do that, exactly.
I remember.
Yeah, we also have, on our website, there is like an NRE list, so if anybody's interested, there is like a list of the experiments we conduct here using this highly advanced equipment and those super fast networks.
I understand the network this year is also a lot shorter and fatter than last year.
Yes, so every year we change our technologies and topology. This year it's more streamlined, especially in the case of the main conference network. We also last year have branched out into two separate networks. We have Science DMZ and Core Network. They have separate AS numbers, and that helps us basically build one network that is more reliable and simpler for the 1 gig, 10 gig connections we have, and the cutting edge technology, highest speeds, the fastest things we have for the researchers right here.
Yeah, there's a lot of universities.
So the funny thing about network being squashed is that very often, like, we try a SciNet when we are building and designing the network, because I'm not sure I can find it somewhere. SC, let's say 24 network diagram, because SC25 network diagram kind of sucks, sadly. But let's look at this. Like, this is a monster of a network, it would seem. But to be honest, you have like 2 or 3 layers. And, okay, and sometimes it's difficult to design a network that has some interesting protocols implemented. Like, there are many challenges in doing that, basically, still. But if you want to implement some crazy protocols, sadly, as with many other things in IT, it only gets interesting if you have like hundreds or 200 routers with more and more layers, right? And we are trying to work within that constraint. By the way, this is, like I said, from the last year. This is the PSNC, this is the quantum experiment. This little thing right here. I'm not sure you can see my my mouse. Okay, yes, you can. So this little thing right here was the quantum experiment at SC24. But still, we are trying to do what we can. And I think last year was, so last year was not EVPN VXLAN. It was last time we used EVPN VXLAN and core network was in SC23. I think Science DMZ is still doing EVPN VXLAN. But yeah, like, it may seem that the network is getting simpler. It may not be implementing some really crazy stuff, but it's still a challenge to basically do, especially if you consider that every vendor is different. Like Nokia, Juniper, Arista, Cisco, like making even the simplest network protocols work in between those all vendors. And I don't mean BGP, I mean like actual protocols like ISIS or RIP, right? It's still a challenge, yeah.
Here, but undergrads as well as graduate student researchers and student clusters. There's a whole student competition. It's like who can spin up the best mini cluster. It's like, here's our Beowulf connection. We got a connection back here, and you have to provide all the infrastructure for all of that.
Yes, so actually the equipment for student cluster competition is donated by their team sponsors. So the actually interesting thing about that is that they have to work within some constraints, like power constraints, not only time constraints, performance constraints. They cannot just bring in the most powerful equipment they have and run it at 1 megawatt. They have to basically work within specified measured limits.
Nice, yeah, that's a lot of fun. What's the coolest thing? Like, what's the first thing you should notice, or what's the coolest thing?
Okay, the coolest thing that I rarely see anywhere else is the Polatis switch. That's the big white thing in the rack 4 that has connected fibers to it. This is basically a programmable level 1.
By the way, that's not the Polatis. That's not it.
Switch.
It's above
you can
this.
tell it that it can switch without plugging the fibers back and forth, that you want the connection go from port 1 to port 16, for example. And the best thing is to, like, it's, I think, $250,000 piece of equipment that you can operate from your smartphone.
Great crossover, yeah, thanks. Yeah, I also think that it kind of went nice. By the way, I think that every year I am saying that the Polatis is the coolest thing there, because there are many, many more cool things. But the Polatis is something that I kind of like have on the verge of what I have to work with. Because, you know, many different teams have their own devices, so I don't even have the chance to work with them or ask them about those devices. But routing does the most jobs that actually are reflected in the success of the conference, whether everybody's happy and everybody has stuff working or not. And I think that Pilates every year is one of the most amazing things that I see there.
I've seen a guy do it.
Well, that explains why the network's a little simpler this year.
Yes, I mean, we basically have the Pilates.
Oh, by the way, he also Wendell might have been under the impression that the network is simpler because this year network diagram is nowhere near colorful as this one. Like, I want to say that SC this year kind of like doesn't even want to show off the diagram. It's like the network is still kind of like this, but I think that due to some weird things happening, we didn't know what vendor will actually go where up to the very last minute. So I don't think we were able to basically print or order prints in time. So that's why I think this year the network diagram is a bit simpler and more like it has more like icons and descriptions instead of actual topology like this. So that's why maybe some people had the impression that the network is simpler.
Pilates every year, right? We also have introduced last year and this year also in our mini HPC cluster, we actually have a petabyte of storage right here on the stage.
So, what is it like? How many years have you been coming to Supercompute?
So I have been coming here for 5 years helping build this network.
Yeah, and I actually have like 5 years badge on my conference badge.
How have you seen it evolve from scientific compute and like AI taking over the universe? You think we're in a bubble? What are your thoughts on the evolution of supercompute?
That's actually a very interesting question. Like in the
if somebody asks you a question and you are not sure how to respond initially and you want to give yourself time, always say that this is a very interesting question or a very good question.
2021, I think, when the conference was back here, it was mostly like after COVID, and so it was very constrained and small, but you still could notice that there is like still a paradigm shift towards quantum. Next year was the AI boom. But what's interesting is that everybody can know where you can buy chips. Not everybody knows how to cool them.
Very cool, my guy. Happy New Year and best wishes from Germany. Thank you. So, I have a very cool story about Germany and power supplies to a data center, which I will tell you in a second.
This is why, especially this year, last year, you can see a shift in conferences like this, not necessarily towards the chip makers, but for the manufacturing of cooling. So everybody can build a 1 megawatt data center. Not everybody knows how to properly operate it and cool it and how to handle power delivery and stuff like that.
Oh yeah, I've definitely noticed the power delivery and cooling. It is really wild to see folks here that have things like, oh, your local utility where you are can't give you enough electricity for your dream data center. Here's our jet turbine you can have on site for a couple of years while they're building out that infrastructure. And you have companies like Eaton that are they feel like the belle of the ball because like we make power and power distribution systems, and now it's like, wow, this is like really upscale power and power distribution systems.
Yes, some people that try and design data centers do not realize how much is a megawatt, how much is a 10 megawatts, how much is 100 megawatts. What do you mean I cannot have redundant power coupling to my data center, right?
I know a guy.
By the way, so like I said previously, now I know why he said the jet turbine as a power generator right next to your data center, because he showed it right here at Mitsubishi.
That he saved a piece of wire that like it was vaporized and black. There was a little bit of it left. But the reason that happened is because all the GPUs in the data center woke up within the same like 1 millisecond window. And the power grid wasn't designed for that.
Oh yes, this is especially a problem that I have heard about on conferences like this. Basically, what do you do when a 10 megawatt data center goes suddenly down and then tries to boot right back up, right? So some power grid suppliers and power plants are big into this problem. Like they're basically telling some customers to, hey, you need to do something about that. It's killing us, basically, yes.
Okay, so I thought I might do better segue into this story, but about power plants and Germany. So my colleague was at a conference about data centers, and they told us some very, very funny story about their data center in Germany. I don't really remember where it was right now, but they had this problem of their power supplies basically constantly switching, like either like getting turned off or switching to another to auxiliary power supply. It turned out that that city in Germany, and I'm trying to like kind of remember all of my facts here and details. That city used some sort of radio signal to like do the smart city IoT thing that was a multiple of 60 hertz, and that interfered with power sinus. So it was like a sine wave, but it was like very choppy. So basically it was like, can I draw online? Oh my God, I've never done that before. Start drawing. So whenever you have sine wave, it's like this, right? But theirs, when they actually look at that with oscilloscope, looked like this. So it was still a sine wave, but it had like this teeth. And the problem is that each and every one of those was like a 2 or 3% drop in voltage, which for the power supply registered as a blackout, brownout, a power loss, or interference in the power grid. So they either reset or switched or something. And one other problem with that is because you can also think about power plants like, okay, for example, imagine you have a heating plant. The plant that supplies heat to your homes. And that heating plant is, let's say for the sake of our example, coal-based. And it's like burning a lot of coal. Like, let's say it's like a 10 megawatt heating plant. If everybody suddenly switches off their valves that supply them with the hot water to heat their homes with, you cannot instantly make that furnace at the heating plant basically stop outputting the 10 megawatts of heat. And it is kind of similar with power plants. If you have a big data center that suddenly disappears from the grid and it's no longer like pulling that megawatts of power, that is a problem for the power company and for the grid, like as a thing. And the other thing is that, okay, so it has disappeared. What happens when it wants to come back up? Because with engines, like electrical engines and stuff like that, you can regulate them to kind of like ease them back into the grid with like even the big engines don't really start by pulling a lot of power with, I want to say, what's the name for that in English? Oh my gosh, I have it on the, oh yeah, inverter, sorry, yeah. With the big engines, you can use the inverters to basically have them soft start, but with the basically typical like resistor-based power usage that the server has, that's not really as simple. So how to basically, like, how to start data center back up and all the workloads again. You cannot just like basically put an on switch on everything and then suddenly start pulling 10 megawatts back where you started, right?
It's wild to see this. You know, thanks for the tour. Thanks for introducing yourself. This is awesome. Supercompute is about supercomputing and not necessarily, like, it's been commercialized, I think, but it's nice to see the academic and the research component.
Yes, that is exactly what we are trying to do here. We are trying to push the envelope forward and maybe tell everybody how cool this is.
Cool, thanks. Thanks for joining me.
Thank you.
So, by the way, the thing that didn't make the cut is that we also like did a tour behind this plexi panel glass, and me and this guy gave Wendell some presents. Like, I gave Wendell some traditional Polish sweets, and this guy gave Wendell some shirts. We also filmed that, but I already know that it didn't make the cut.
Wendell, nice to meet you.
Nice to meet you again.
Finally.
You're working on all kinds of exciting stuff with XE, CSS, and Liquid, what was it?
fluid simulations.
Fluid simulation.
Fluid X3D. So
Fluid X3D.
I'm Moritz Lehmann. I work at Intel. I'm the engineer behind the XeSS super resolution and frame gen GPU kernels.
I saw that on mobile.
Yeah. I recently made it compatible even with Meteor Lake, despite Meteor Lake hardware lacking the XMX unit. With all the optimizations, I got it fast enough to run on the MSI Claw first gen, which is absolutely amazing for all the people who bought it already. And here at Supercomputing, I'm also with the Fluid X3D software. I'm wearing it. So this is my own software. I do it as a hobby project. You can run aerodynamics, aeroacoustics at very large scale. Last year I demoed it on Xeon 6 running in 6 terabyte memory with over 100 billion grid cells.
That's the same 8800 setup we were using for AI, but he's doing it with 6 terabytes of memory, probably one of the largest installations, because inferencing on AI and computational fluid dynamics depend on random memory access going fast.
It's absolutely mind-blowing that we have such large memory capacity on a single computer already. And this year at Supercomputing, I'm demoing Fluid X3D on multi-GPU with the Arc Pro B60 workstation GPUs. Over at the Intel booth, we have a workstation with 4 of them to pool together 96 gigabyte VRAM. So that lets me run and render 1.8 billion grid cells in real time. That's a special thing. Industry can only dream about such large resolutions, and I'm running it in real time even.
Yeah, B60 already up and running for scientific compute. I'm still working on SRIOV, but B60 is pretty exciting to see a 96 gig pool just hanging out.
Yeah, and that is the software is written in OpenCL, so it is universally compatible with all of the hardware, from low-end toaster hardware that is 15 years old up to the highest-end data center GPUs. You can even put AMD, NVIDIA and Intel GPUs in one workstation and have them run together, pooling their memory. It's like a cursed version of SLI.
And you're putting it on GitHub.
And it's on GitHub. It's for free for educational and research use.
Nice.
Go try it out.
Very, very awesome. Very nice to meet you, and thank you for the shirt.
You're welcome.
Thank you.
Nice to meet you.
Oh, by the way, I can see my reflection of me fiddling down the phone. Yeah, by the way, this guy was like kind of awesome. Like, I mean, I didn't like get to talk with him more because we did the tour of that right after. But it's crazy, like how many people kind of recognize Wendell. Like, not many people in Signet recognized basically YouTube people like Wendell of Jeff Gerling, because Jeff also was at the Signet this year, at the Supercomputing this year. But so many like random people from other like companies did.
I ran into a Wild Allen, and it turns out that Solidigm is showing off liquid-cooled M.2, and it sounds insane, but they're 25 watts. There's 5 of them here. This is like 125 watts.
By the way, at Solidigm, like so many YouTube people stopped by Solidigm, and Storage Review, Wendell, Jeff Gerling, and I think I also I also saw one other person.
Of cooling that you have to deal with, and if you've got an all liquid cooled server, what's going on? Yeah, so you can have the giant heatsink, or you can have more room for more E1 drives. And the mechanism,
running cooler.
Yeah, running cooler. The mechanism moves a thermal pad on and off of the metal. It's kind of nuts.
It's good stuff.
I also ran into Cornelis Networks. Yeah, OmniPath. Remember the video that I did on OmniPath? This is a competitor to InfiniBand. I'm keeping my eye on them, and they were showing off their 400 gigabit networking platform. This network is already in use in certain supercomputers. It was part of the build out for supercomputers, so they're going to be around for a long time, but I want to see where they go from here. I want to go fast. I want to use this network, not just for CUDA, but also maybe something on the AMD ROCm side of things. I think it's possible. This has been a wrap for Supercompute 2025. I had a lot of fun in St. Louis, and I get to hang out with some old friends and make some new ones and get the inside scoop to understand how academics are using this fancy new hardware for AI research and, well, basically any academic topic. See, I want to understand better what's going on, how it's being built, and how the pieces fit together. And this event was tremendous for me in terms of leveling up my understanding of how people are using the tools today. I don't want just the marketing stuff. I want to understand how these academic institutions, universities, and businesses are using these tools, the new tools, like how it all fits together. So making those connections and making friends with people and getting access to systems is a big part of why I went to this event. I'm Will, this is Level 1 Techs, and I'm going to see you in the next one. If you have any questions or I miss anything, feel free to hit me up in the forum. I'm signing out, and I'll see you there.
Yeah, so basically, by the way, I would want to have maybe a quick glance at this here. Okay, in the SCC on site. Okay. Yeah, so I have to say, like, Wendell still like managed to. I wonder if he'll make more videos about SC. After this one, I'm not so sure, but it's like, you know, you go to this conference, and especially like I was basically working there, right, as a part of Signet, and then you witness everything, and then you see everything, and they're like in your head, oh my god, this is like a content for days. Then it turns out that you would actually need this conference to last for a week, not 3 days, in order to properly film everything and talk with everybody. But also what I wanted to show you maybe, and I'm not sure whether we will see this, because Wendell said that it's the best place to basically chat with people about what they are doing. And I have to say, I totally agree. I just want to catch maybe a frame where it has more of the academic units, because that's totally the thing I did. And I think I saw one. Oh, yeah, that may be it. So, for example, back there you have JAXA. JAXA, if you don't know, is like a Japanese space agency, basically Japanese NASA. But there's like a whole lot more booths that are basically universities. And this is super cool because you can basically go over there to the professors, to the people being there. Most of them, there are most often the professors, right? And you can talk with them about what they are doing, how this works, what are they running on it. You actually can get some non-bullshit, non-marketing, actual knowledgeable person to talk to you, and actually, you know, they will not bullshit you. They will actually talk about the things they're doing. And what I did this year, because I finally got some proper audio recording equipment, is I caught the architect for Fugaku, for the Japanese supercomputer hailed as the most beautiful. And I did a very, very quick basic interview with him. Like, sadly, without any video, but the audio is still very interesting, about what makes a supercomputer and why do you design a supercomputer the way you design it, right? So I think that if not the next, then in a very some next videos on my channel, I will probably be able to publish that and edit that somehow. But yeah, like Wendell is right. Like I know, like in this video, he mostly showcases, I don't know, Gigabyte, AMD. Then he talks with some other random people, that person that actually is not okay. So Mortis is very interesting in a way that he is actually like an Intel representative. I really hope, like nobody at Intel thought that, you know, that this was like an unauthorized speech. So I really hope that nobody like slapped him for that, because I do know that those things can happen. Like last year, I wanted to record people at HPE explaining to me some InfiniBand stuff, and they were basically like, no recording at all, no nothing. You can only like take your notes with pen and pencil if you really want to. But this year, there was a shift in this, I noticed, and I'm not sure if whether it was communicated or not, but I literally had in previous years people basically take their chips and hide them under the desk whenever they saw me with a camera, which I thought was like crazy. Like, why are you coming here if you do not want to showcase this stuff? Like, but yeah, I am very happy that this got published, that this did make the cut. Wendell was a very super fun person to talk to. Also, shout outs to Wendell's camera operator. You also were a very cool guy, and I also enjoyed chatting with you a lot. We also met Jeff Gerling, and I don't think I have to introduce Jeff Gerling to anybody, but we also met one other person from one interesting place on the internet, and that's Chips and Cheese. Now, I have to say this is the absolute worst name for a website that does an actual reviews and news articles about HPC or supercomputer hardware, or, you know, computers in general. But this is a very good news outlet that actually does some, I want to say, non-trivial reviews and news articles. So if you are into the more advanced side of computers, HPC, computation, stuff like that, definitely check out the chips and cheese. As weird as that may sound. But yeah. So for people at YouTube, sorry I had like, you are probably here kind of late because only after 20 or 30 minutes I noticed that I am not streaming like publicly. So if you are really interested, you can go back and check out the VOD later. But yeah, that's what I wanted to show you today. That's what I wanted to watch with you today. Oh my god, I was really like scary how this came out. By the way, this shirt I have on me, super cool. Guardians of the Network, like Guardians of the Galaxy. I need to wear this more for my videos. And actually, yes, got recognized for actually shouting out. Yeah, so time to enjoy the rest of my Sunday. So you also have a great day, and thank you for watching today. I hope you'll be with me next time. Bye.